Question 4, working with composite functions. We have for the function f of x equals 7x plus 2 and the function g of x equals 3x, find the composite function and state the domain of each function. So the first one we want to figure out is what is f of g of x. So again, the way we can write this is f of g of x. Notice how we have what's inside here is going to be substituted into the f function. So if I draw this out, this is going to be the f function here. And the f function says you're going to have this 7 times something plus 2. So what happens is what's being substituted in this function is not actually a value, it's actually a function itself. So what happens is the g of x function, which is the 3x. The 3x actually goes in place of x in the f function. So where there's this x, this 3 of x, this 3 times x is actually going to replace x there. So it's going to become the input value. So input values do not have to necessarily be numbers. They can also be expressions. So this 3x is going in place here, like so. So if we do the math, we're going to have 7 times 3x is going to be 21x. And then if you add 2, those aren't like terms. So it will stay as that 21x plus 2. So what happens is we now want to state the domain of this function. So it says type in inequality, use integers or fractions or any numbers, use comma to separate answers as needed. Notice though, this is just linear. Linear, there's no domain restriction because you can multiply 21 by any number and add 2 to it. So there's not any domain restrictions. Remember, you have to have fractions where x is in the denominator or a square root symbol where x is inside the square root symbol. And neither of those are here, so there's not going to be domain restrictions. So the domain of f of g is going to be all real numbers. So notice how the g of x function is actually being substituted into the f of x function. So if I want to evaluate f of g of x, what's happening is the g of x is 3x. So this turns into f of 3x. So then we turn to the f function, which says we have this 7, and then notice that we're going to replace x with the 3x. That's what's actually going in. So the 3x becomes the input, and then we're going to be adding 2 to that. So if we do the math, 7 times 3x is going to be 21x plus 2. Those aren't like terms, so that's going to be our result. So part B, we have to evaluate g of f of x. So this time we have g of f of x. So this time, if we look at it from a drawing perspective, g is our function. Notice that fx becomes our input. So that f of x was that 7x plus 2. So that 7x plus 2 is going to drop in to the g function, which was this 3x. So you have this 3 so we have this 3 times, and then we're going to replace x with the 7x plus 2. So if we do the math, 3 times 7x is going to be 21x, and 3 times 2 is going to be 6. So 21x plus 6 comes out. So so g of f of x is going to equal this 21x plus 6. So 21x plus 6. So again, we're still back to the same thing as far as domain goes. We don't have any domain restrictions. So the domain of the g of f function, this composite function, is going to be all real numbers. So again, notice how if we do this without the map of the graphic, notice how if we have g of f of x, this really means g of, and then what is f of x? Well, it was 7x plus 2. So that means that the 7x plus 2 is going to go into the g function. Well, the g function was this 3 times x. This is going to be 3 times then this 7x plus 2. So that's how that 7x plus 2 is going to go in to, it's going to replace x in the g function. So if we do the math, we get again this 21x plus 6 would be the math. So if we have f of x, so again, this really means f of x. So notice how f of x was this f of x was this 7x plus 2. So this becomes then f of 7x plus 2. So we replace this f of x with what it is, and this becomes the input value. So in my function, we're still keeping the f function, but notice how this 7x plus 2 is going to go in place of x. So we're going to have this 7 times the quantity. X plus 2 is going to go in for x. I'm sorry, 7x plus 2 is going to go in for x. And then we're going to be adding 2 to that. So 7 times 7 would be, that's going to be 49x. 7 times 2 is going to be 14. Plus 2 will be 16. So 49x plus 16 is what's going to be coming out. So f of x is going to be 49x plus 16. So that's going to be, again, the domain is going to be all real numbers. Again, there's no domain restrictions here. So notice how, again, this becomes the input value. This is what's going to replace x. So notice how, again, we're going to have this 7 times the quantity, and the 7x plus 2 goes in for x in the f function, and then we add 2 to that. So that's going to be 49x plus 14 plus 2, which is going to be 49x plus 16. I can kind of see it better still by drawing pictures, but if you don't want to draw the pictures, you can kind of try to see if you can just do it pure algebraically. But if I draw pictures, I may want to make my picture a little bit bigger. So again, when you see this little circle, that means we have a composite function. So composite functions means you're substituting a whole function into another function. So g of x is what we kind of have going on here. So g of x was 3x. So this becomes then g of 3x. So what this means is this 3x is going to become the input into the next move. So again, we're using the same function, so we have this 3 times, but what goes in place here is actually this 3x. It goes in place of x. So this function becomes then 9x. So 9x. Again, the domain is going to be real numbers since it's just a linear function. If you want to do it from a graphic perspective, you can maybe make it a little bit bigger. So what's happening is our function is the g function, and the g of x is what's going in it. So this 3x is going in it. But remember, the g function is 3 times x. So that means what's going in place of x is this 3x. And so when we do the calculations, we just end up with this, this 9x is coming out. So that's how we can kind of see it from a drawing perspective. Okay. So that was question 4.